So let's say a block mass M moving at V naught on a rough surface. Mu. How far will it slide? We're going to do it with generic terms only, no numbers, right? Variables only. So the motion picture is such that the block is here. It's moving with an initial V naught. It's going to travel across a horizontal displacement, which is the question. End up over here and stop. For argument's sake, we're going to define going this direction as positive. And we can look at the vertical direction up as positive y and forward as positive x. Right? This is back to motion fundamentals. So when I go through my problem-solving process, I know V naught, I know V final, I'm looking for D, I do not know A, and I do not know time. In order to solve for D, I have 1, 2, I need at least one more variable. Time seems rather challenging to discover without knowing those others, but I can absolutely find the acceleration. Right? So we use Newton's second law, sigma F equal to ma, in order to solve for A. Which dimension is the acceleration in? In the x direction. So in reality, I need the summation of the forces in the x direction in order to find this acceleration. If I go back to my picture, I can predict that since it's moving forward at V naught in a positive manner, the only way to slow down would be if acceleration was in the opposite direction. And so I expect my acceleration to be a negative value. I'm not putting a negative number in, I'm expecting to get a negative number as an answer. Right? And so in order to do the summation of the forces, I first must look at the free body diagram of the block. So if I draw the block sitting on the ground, I know that it has f of g going down and f of n going up. Well, in problems, you will have numbers. But until then, you don't need them. And so now I know that there must be a friction force acting to the left, because as the block slides forward, friction would resist the motion going backward. Furthermore, friction is the force that generates the deceleration that brings it to a stop. Is that your question? Right, it's deceleration. Exactly. And so, firstly, I always start with the summation of the forces in the y direction. And I know that you know it's at equilibrium, but we need to know f of n, right? Because in order to find the friction, right, we need to know mu and f of n. We're presented with mu, and so to find f of n, obviously it's equal to f of g. Now you could jump to that conclusion, but for argument's sake, I'm defining exactly how to solve. So f of n minus f of g equals 0. This is because ay was equal to 0 in this particular example. So f of n is equal to m times g, where in this case, since I've already put the negative sign in for the direction of the force vector, this is the absolute value of 9.8, or just positive 9.8. That makes sense? Do not double repeat the direction. In the horizontal direction, as we just saw a moment ago, f of f is the only force horizontally, but it points in the negative direction, so f of f is negative. And that's exactly how I get my negative a. At this point, right? I can include the fact that I know mu is f of n times, or f of f is mu times f of n, right? And so if I put in the fact that I know that this is mu times f of n, and that is equal to m times a, I can then introduce that this, mg, is f of n. And so now I have mu times m times g equal to m times a.
Wait, can you move it down?
Oh yeah, sorry. Right, I use the fact here that f of f is equal to mu times f of n, as defined. Right.
Mu times m.
And I just, sorry, I neglected the negative sign that goes right there, right?
Negative mu times mg.
Right. And then in this case, right, the mass on both sides divides out. So now I know that the acceleration is negative mu g.
Oh, you multiplied to get.
Right? I know what g is, that's 9.8, and mu is given in the problem. So when I take that and I go back up here and go, now I know what a is, right? I fill in my list what a is as negative mu times g, and then I can simply solve with my motion. V squared equal to v naught squared plus 2ad, all in the horizontal. So I know that this is 0. I know that this is v naught squared plus 2 times negative mu times g times d. And then through some algebra, I get v naught squared divided by 2 mu g equal to d. When I subtract this v naught, that becomes negative. I divide by that negative. I get positive value, which indicates positive displacement, which is forward, which makes complete sense.